Space situational awareness is involving largely the detection, tracking, and characterization of all objects and environments on orbit. There are on the order of 20,000 space objects up on orbit right now that we consistently track and catalog in the Space Object Catalog. Now those combined objects cause on the order of 100 or so collision warning events each and every year. And I think last year the International Space Station had to maneuver a number of times to actively avoid colliding with bits of space debris. Riconzo in particular is transformative towards the space situational awareness problem. And this is largely because current assets are radar and optically based systems that are typically run from the ground, and a couple particular instances are also run from space. What Riconzo does is it provides a wide field of view, large aperture optical payload that's on orbit persistently all the time gathering information. So it doesn't have issues with weather or with ground problems. Whenever there's a power outage on the ground, it's not also out. So it's just up there all the time gathering data. So the fact that we use off-the-shelf hardware means that these satellites, like Riconzo, are rapidly composable, meaning that we can send up one, we can theoretically buy 10 copies of all the bits and pieces, put them together and send up 10, 20, 50, 100 of these. And that really helps us get a handle on this space situational awareness problem vis-a-vis detecting and tracking space debris.
So there really is a revolution going on in terms of small satellites. And one family of small satellites is called CubeSats. CubeSats are very small objects on the smallest scale, 10 centimeters by 10 centimeters, so 4 or so inches on a side. And this revolution started about 10 or 15 years ago when a couple of faculty members came up with a standard concept for a tiny spacecraft called a CubeSat. And they also developed a method for deploying CubeSats from launch vehicles on secondary payloads. So the real payoff of this small satellite revolution is being able to launch lots of these small satellites very cheaply, because you might have a big Department of Defense spacecraft that's going up into orbit. You need a launch vehicle to launch that. Launch vehicle might have extra carrying capacity that you can deploy small satellites from.
My name is Adam Snow, and I'm the program manager for the Riconzo mission.
I'm Johnny Worthy. I'm the Chief Systems Engineer for the Riconzo mission.
And we're here today to tell you a little bit about our mission. Our mission is going to offer persistent space situational awareness. We're going to do that through the passive observation and detection of space objects using a wide field of view optical sensor. We'll employ automated image processing on board our spacecraft, which we're developing through the use of almost entirely commercial off-the-shelf components, so we can build it really fast, it integrates really well, but also still provides a lot of capability.
But the most important thing about our demonstration is that we're able to detect and track objects. So the Riconzo mission contributes to SSA by detecting and tracking these objects. So what you have here on the display is a video of images captured by the ISS, and we use our flight processing algorithms on those images to pick out the stars and pick out the objects. In blue we have the stars that are detected, and in green we have the objects, and we're able to just differentiate between the two by looking at how they move.
Recently we competed at the flight competition review with the University Nanosat program, where the Air Force selected us for Phase B funding. And what this means for us is this is not only a development opportunity for us as students, but this is actually insured to be an actual flight program. So in conclusion, Riconzo is going to be an incredibly valuable mission for all parties who have interests in space assets. The military, governments, even the commercial sector want to protect their assets in space. And we're going to do that through persistent space situational awareness. We're also going to do it through a disaggregated and fractionated system. That is, instead of utilizing one large spacecraft, we'll be able to deploy several small spacecraft to replicate those performances. Also, we're developing this rapidly through the use of commercial off-the-shelf components, leading to a highly scalable system.